All right, everybody, let's do a condensation reaction for esters. So you should have already watched the video on just a basic ester mechanism. And so what we've learned is from our name. So here's our ester. So we know that from our name, the butyl part, that the first part of the name is always the alcohol, and the second part is always the acid. So from this we know that we're going to have butanol right here. So this would be butanol. And then right here the acid on this has to be the propanoic acid. Okay, so we're going to take butanol plus propanoic acid, and that's going to make our ester compound, which will make our butyl propanoate. And we should remember from the previous reaction, the way I wrote it out is it actually has an equilibrium where it goes back and forth. And so we need some energy to drive the reaction. And so typically, like sulfuric acid is used, some sort of strong acid. You can use different types of acids. In lab, we would use a concentrated sulfuric acid. So what you can write is, we know that there are hydrogen ions that are being added, and we're also going to add heat into the system. Into the system means into the reaction itself, into everything that's combined. And so if we have the extra acid catalyzing it and we have this heat, it's going to drive these two separate reactants together to end up forming our ester. And then of course, since this is a condensation reaction, when it condenses, water is going to be pushed out. Remember, the other name is dehydration synthesis. Okay, so remember the other name for condensation we know is dehydration synthesis. So from that we know that dehydration means we're going to lose water, and synthesis is a process of making, of putting things together, right? So let's go ahead and let's put this together. So we have butanol. So but we know is 4, right? So that's 1, 2, 3, 4, and we're going to have the alcohol on the end. Without anything else in the nomenclature, in the name, we just assume that the alcohol is on the end of carbon 1, so we can just assume that right there. Without any other names to it, we just assume that, right? I'm not going to draw the hydrogens, but you know that there are hydrogens here. I'm just going to draw the bond lines where they're at. On your notes, you should definitely draw the hydrogens. I'm just trying to make this video a little bit shorter, but just so you know, there's hydrogens. Anywhere where there's a bond, there's always hydrogens. Make sure you're doing that. Propanoic acid, we know propane, that would be 3 carbons, so we're going to have 1, 2, 3, and then this carbon over here, we're going to go ahead and put our carboxylic acid. And then of course there's hydrogen, 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 and hydrogen, right? So, wow, that's pretty bad. So we have our hydrogen ions, we have some heat into the system. If it were to cool down, it would go back in that direction, so we know we can automatically add our equilibrium arrow, right? And so now we just have to combine everything together. So remember, we know that the OH, the hydroxyl part of this carboxylic acid, combines with this hydrogen over here, and then if I remember correctly, we've just been highlighting that to say, hey, all of that is what's removed, right? And so that's going to lead, that means this oxygen will now bind over here with this carbon. So remember, always, I would recommend go with your ester first. Start with the ester linkage first and then build outward. I think it's a lot easier for you that way. To be honest with you, it's easier for me. That's where I always start. It's the way I was trained, and it's just, to me, this always made sense. If you don't have to do that, you do it whatever way works for you, just so long as your compounds are properly written. That's really all that matters. So we know that this oxygen here is this one, so there's 4 right there, so we're going to add our 4. 1, 2, 3, 4 carbons. Wow, that is pretty bad. Alright, so 1, 2, 3, and then we're going to add in the rest of our hydrogens. And then this carbon here, double bond to oxygen, we have 2 more carbons on there, right? So we've got 1, 2, and then we need to add in our hydrogens, and then of course water came out, so we need to make sure we include our water. Okay. So again, you know all these are hydrogens right here. So this entire thing here is our butyl propanoate, and then right there, there's our ester, right there. Okay. So now what we want to do is, remember we know that we're going to write let's write a balanced chemical equation for this. So we have all of our products. Looking at this here, we could look at each of these. We could look at this alcohol, we look at this acid, we can look at our ester, water's H2O. We already have the compound formula for it. But looking at that, we can just basically count atoms, and we know that for our alcohol, so all of this is the R group, and then there's an OH. Right, so we have an R group, and then we have our COOH, right? So we have our R group and then COOH. I'm going to come over here and let's see, let me get my eraser. I'm going to get rid of that bond line right there, just so we can get in the habit, so when you see this you don't get confused. Back up, there we go, R OH, so R is everything right here, R is all of this right here, and then the COOH, right? And of course, we want our equilibrium arrow. And then typically these esters, so the formula for an ester tends to follow the concept of is the R COOR and then a prime. I was just trying to think how to basically say that to you without confusing you as far as your different stuff goes. But you should recognize that COOR, the COO part, this part right there, COO, this R prime is actually this part right there, and then this R is this right here. Okay, so you see how you have COO, so there's your COO right there. And COO. So don't let this confuse you. A lot of times if you look in a textbook or online, the way these things are written is this part is written on this side and this part is written on this side. What I have found over the years is it can be a little confusing when you first learn this stuff, when you see things written in different order, so to speak. So when you look at the name, the alcohol comes first in the name, and then we use the acid part. So for me, what I like to do is, I know that this is the standard way of doing it, but for me what I like to do is just keep the ester written in the same order that we have it. We have the alcohol, there's the alcohol, and then there's the acid part and the acid part. So just know that this right here is the standard way of thinking about it. For us, what we're going to do is just think about it this way: R prime COO R. R prime COO R. Okay, so we're just going to write it kind of in that direction. That's all we're going to do. Let me move. I'm going to move this part. Oops. Let me move this down. There we go. Just trying to make some room. All right. So then we're going to have our R prime COOR plus water. So anytime we write a chemical equation, we're following this right there. Okay. All right. So right here we've got, so there's 1, 2, 3, 4. That's 4 carbons, right? 4 carbons. We've got 2, 4, 6, 8, and 1 more is 9. So that gives us 9 hydrogens, and then we have our hydroxyl group on the end. Okay, we've already talked about that, so that should not be anything new. And then right here we have the COOH. This whole part here has to go last, so the R group would be this right here. So that's C2, H2, 4 and 1 is 5, and then we have our COOH. Okay. Recopy this. We need heat. It's going to go back. And then all we do now is we just write all this stuff down right here. That's it. So the R prime right here, we've got 1, 2, 3, 4. So that's 4 carbons. 2, 4, 6, 8, and that one right there, that's 9 hydrogens, right? That's the 9 hydrogens, right? And then we've got the COO. And then we've got 1, 2. 2, 4, 1 is 5. Plus H2O. Now again, if you look this up online, it won't be written in this order. It would be written, it's this right here is this order right here. Okay? So, you know, I'm teaching you what we just did right here because this is how we write it. And this is what we normally do, is this right here. But you should be able to get in the habit of writing your final answer in that format right there, because that is the standard format. So as a result of that, then what we're going to do is rewrite this. So your final answer should look like this: H9OH plus, all I'm doing is recopying all of this right here, H5COOH plus, there's our heat. And so what we should put first, we should put this part first right here. All right. It should kind of go in reverse, where we put this side first. So let's put the C2 H5 COO, that's our ester that's combining it, and then we have C4 H9 plus our water. So our final answer for the balanced chemical equation right there. This right here, this is our chemical equation right here. All right. Not too bad. So 7. So if you look at this, right, it's all the atoms are accounted for, because everything we started with on this side was right here, and all we did was pull the water out. Okay, so we've accounted for all the atoms. So now the last part of this problem is calculate formula mass and molar mass for the weight of the ester products. All right, so, or the ester product. Well, that's this right here. Okay, so what we can do is remember, this is the formula for it, but now what we want is we want our empirical formula. Remember the empirical formula I had talked about in class. So the empirical formula is where we basically are, for this type of compound, we're going to put all of the letters together. Just keep them in order, knowing that the standard is carbon, then hydrogen, then oxygen, and then everything else is in alphabetical order after that. So carbons we have, so we're going to write, we got C, there's 2 here, plus 4, that's 6, plus this one right here, there's 7, so C7. Then we need our hydrogens. 5 and 9, there's 14. And then our oxygens, we have 2. So here's our empirical formula right there. All right, so from this problem, now we can come up here, we can figure out formula mass, and that's the basic Chem 1 skill, which I'm going to review with you in case you've forgotten it. And then molar mass, and molar mass, once you figure out formula mass, molar mass is pretty easy. So for the formula mass, we need the mass of the formula, obviously. Okay. So we have carbon, we have hydrogen, and we have oxygen. So now we just count everything. So there are 7 carbons, there are 14 oxygens, or 14 hydrogens, sorry, 2 oxygens. So if you look at your periodic table, 12.01 AMU is the weight for 1 carbon atom. Hydrogen is 1.01 AMU, and oxygen is 16 AMU. Okay. So if you take out your calculator, let's see here. So we got 112.01 times 7. That gives us right here 84.07 AMU. We've got the 14 times 1.01, that would be 14.14 AMU. And yes, I am writing all the units because remember, you always have to include a unit with your number. And then 16 times 2 is obviously 32 AMU. I know it looks like a 6, so let me fix that. If we add all this up together, so we've got the 84.07 plus 14.14 plus 32, we should get, let's see, make sure I did this, hang on a second, let me double check, 7 times 12.0, I keep hitting the wrong thing, 7 times 12.01, yeah, 84.07 plus 14.14 plus 32. Everyone, hopefully you've double checked my math, but I've just double checked it again because I kept punching the wrong number in. 130.21 AMU. So this right here is the formula weight, the formula mass for 1 molecule. This right here represents 1. Wow, that is pretty bad handwriting. Represents 1 molecule's mass. Alright, so now let's do molar mass. So molar mass, think back to Chem 1, is the mass if we had 1 mole of substance. Well, we know 1 mole of substance has Avogadro's number, 6.02 times 10 to the 23rd molecules or atoms of that substance, or ions, or whatever the case might be. Well, if we had 6.02 times 10 to the 23rd of this 1 molecule over and over and over again, we would get a huge number. If we divide it by the total number, we still get 130.21. But at this point, since we have so many of these molecules and so many atoms bonded together, at this point it registers on a scale. And so we know that we would have 130.21 grams of this particular substance, okay? Of this particular substance of C7H14O2, and that would be per 1 mole of this substance. So this whole, that's a 2. So this right here, this whole thing, that is molar mass. Molar mass is the ratio of grams per mole. Grams per mole. Grams per mole. So if you had 1 mole of this, you have this. If you had half of a mole of this, you would have half of this number. If you had 1/4 of a mole of this, you'd have 1/4 that number. If you had 2 moles, you would have twice this number. It's pretty easy. And this right here is that's it. I think we've answered everything. We had to do the condensation for the alcohol and the acid for the ester. We've learned that this is the basic formula for an ester. You have the ester link, and then you have your R group, and then the other R group, so R prime. So you have to give it an R prime. You have to do something to, it's like R1, R2. It's kind of the same concept. And the way we write it, we tend to take this and reverse it. That's the only reason I wrote that here, is to not confuse you, just to show you that the way we're writing it is reverse of the way it normally should be done. So then what I did was show you the basics for an alcohol, an organic acid, the ester in the form that we write it, and then we wrote all that out. And then knowing that this is the proper way to write it, all I did was take the formula here and reverse it. I kept the ester in the middle, and I put this part in the front and this part in the back. And so this is the way we should do it all the time. So just know that we're always going to write we'll write our compounds in this way, but when we write the final formula, it should be written with this first and then this part. And then remember, this is the empirical formula, which is all of these atoms combined into one simple compound formula, for lack of better words, where all the atoms are together. All right, that does it for this problem. We'll do another one later where it's the hydrolysis, where basically it's the reverse of this, and we'll do some more calculations. Hope that helped. I'll talk to you soon. Bye.